The document, A Framework for K-12 Science Education, outlines the vision that Dr. Quinn just described and is the foundation of the Next Generation Science Standards, or NGSS. But these two documents do much more than just describe new standards. They provide valuable context around the standards that can be incredibly useful for helping us interpret the goals and intentions behind the performance expectations. The process we use to interpret the goals of a performance expectation include referring to a number of resources, which include the full performance expectation itself, and we'll discuss in a minute what we mean by that, the National Research Council's Framework for K-12 Science Education, and please note that many states have their own frameworks related to implementing NGSS, but that's actually a different document with a different purpose. This is the framework that was used as the basis for constructing the NGSS, also called the NRC framework. The NGSS also has appendices on the disciplinary core ideas, science and engineering practices, and cross-cutting concepts. And we'll show you how we use all of these resources by continuing to explore our natural hazards example. There are links to all of these resources below this video. In order to decide what the goals of a PE are, we'll first examine the full performance expectation. Then we'll look to the framework and appendices of the NGSS to get more context and details to help us better understand what is expected. This process is sometimes called unpacking a standard. This process has always been part of the design of curriculum and assessment, but it got a bit complicated with NGSS when the three dimensions were combined. And I'll warn you, this part of session 2 is pretty dense, but it's an incredibly important process for every aspect of NGSS. You'll do the same process on your own when you do your first assignment, so bear with us. So let's begin by taking a closer look at the PE itself. We often see people using the PE statement, such as the one shown here that you've already looked at, to interpret expectations for students. One of the most important messages that we can communicate about NGSS is that the PE is really the bold statement plus all of the information in the three colored boxes below it, the three dimensions. The PE statement is a sentence that shows one way to combine pieces of all three dimensions, but in combining them in a concise sentence, some information, often very important information, is obscured. The truth is, when we articulate the goals of a PE, we often completely ignore this bold statement and focus only on the three boxes below. We'll spend a few minutes now walking through the text of those boxes to see how reading them shifts our understanding of what is expected of students. Let's begin by looking at the science and engineering practice. For this performance expectation, the practice being assessed is analyze and interpret data. This practice description gives a bit more general information about what grade-appropriate analysis and interpretation looks like in middle school. But the specific part of analysis and interpretation that students should be working on with this PE is to analyze and interpret data to determine similarities and differences in findings. It's not completely clear what that means, and so we'll try to find some more information from other resources in a minute. To help us record our ideas about the goals of a PE and what we want to learn about our students, we take notes in what we call a PE unpacking table. As we work our way through each part of the PE, we'll fill in these empty boxes here, and later we'll use what we identified as the component idea of each dimension as a guide when we analyze a performance assessment to decide what information it's providing that we need about students' progress with the PE. And we'll also use it to plan how we'll collect evidence of the parts of the PE that are not being assessed, though that's beyond the scope of this course. Right now, we'll zoom in on just one dimension at a time as we fill out the table just so you can see it better. Sometimes it's helpful to highlight the verbs and nouns to bring our attention to the most important parts of the statement. Notice that just like the PE statement, analyze and interpret data are both goals. Specifically, students need to be able to analyze and interpret data to find similarities and differences in findings. We'll try to shed a little more light on exactly what they mean by analyzing and interpreting similarities and differences in findings. In the general description of the dimension for the middle school, it states that students should be using basic statistical techniques of data analysis. Now, we don't know yet if there are specific types of analyses or statistical techniques that middle school students should be learning about, so we've only begun to unpack this dimension. Now, let's look at the DCI. Let's first highlight the verbs and nouns. The content students are expected to know as part of this PE is that mapping the history of hazards in a region, together with an understanding of related geologic forces, can help forecast future events. Notice the emphasis is not knowing how a hazard happens. Rather, it's about knowing how historical data and knowledge of the forces that drive hazards can help inform predictions about future events. So an assessment that just focuses on what causes an earthquake is not going to address the needs of this disciplinary core idea. It's also important to note that the text of this DCI doesn't tell us what natural hazards are going to be assessed and to what degree they need to understand the geologic forces behind them. So again, we'll look for some more information in a few minutes. But for now, we can note what we did learn from the DCI. Students should know that data from past hazards can be used to make predictions about future hazards, and that spatial data for hazards, together with information about geologic forces, can be used to make predictions about the future. I want to call attention to something sort of strange about this DCI. The way it's written, the goal is for students to know that data for hazards can be used to make predictions about future hazards. The DCI alone doesn't say that students should be able to use patterns in historical data to make predictions, but when we consider the DCI together with the practice and cross-cutting concept, we know that it's a reasonable expectation. We don't just want students to know that data can be used. We want them to know how to use the data to make predictions. So we're unpacking the DCI with the knowledge that the meaning of the DCI actually shifts when combined with the other dimensions. Of course, there are a lot of things students would need to learn to be able to do these things. For example, in order to know how data from past hazards can be used to make predictions about future hazards. For the DCI in particular, it can be useful to brainstorm all of these learning goals embedded in the DCI statement, and that is all of the things students would need to know to be able to show proficiency with this standard. These are some of the concepts that I would want to know that students were able to use when analyzing and interpreting data, and each one of these bullets itself requires some unpacking, but they give us some more guidance about the kinds of things we need to assess or at least see evidence of in some way to support students' learning of this DCI. Also, the bullets would be very different depending on who is teaching or assessing the standard. For example, the last bullet focuses on the geologic forces used to interpret data relevant to earthquakes, but if I weren't teaching or assessing earthquake patterns, I would unpack this DCI very differently. If we were writing an assessment or curriculum, we'd want to go much further with the unpacking. But for just analyzing an assessment, this level of unpacking should work. All that aside, this gives you an idea of the first level of drilling down into the main ideas of a DCI and the component ideas required to support students in learning to use that DCI. Now let's look at the cross-cutting concept, patterns. For the sake of simplicity, we'll leave the connections to engineering and technology out of our analysis. So the cross-cutting concept here is patterns. Specifically, students use graphs, charts, and images to identify patterns. Still, we don't know much about the kinds of patterns we should be evaluating. Certainly, middle school students should be able to look for a trend in a bar graph, but what other kinds of patterns? Should they be able to do things like look at data on a map for the amount of damage from an earthquake in a region and find the variables that might cause increased damage by describing spatial patterns? You can probably see that once you add the expectations for 3 separate dimensions together, the possibilities of what we might do with students are multiplied. But this increases the challenges for us as we try to isolate exactly what we need to know about our students. We need to find some way to constrain the possibilities while we break down the boundaries of what we've traditionally expected students to do. The full text of the three dimensions are not the only resource on the PE that gives us guidance. The clarification does crucial narrowing of the scope of the dimensions and is specifically written to give guidance for assessment. Beneath the text of the PE is the clarification statement. On some online repositories of the NGSS, like NGSS at NSTA, you will have to click a link below the PE to reveal the text of the clarification. Some important insight we get from the clarification is that we should focus on earthquakes, volcanic eruptions, severe weather, and mass wasting, which is basically landslides. It also provides examples of types of data students should be ready to work with, including locations, magnitudes, and frequencies of hazards, and that students should be ready to use analyses to inform mitigation efforts on a wide range of scales, from local to global. Built into this guideline is more insight into the kinds of data that students might work with, such as maps that show past locations of hurricanes and fires, and spatial data about risk related to hazards such as drought, and other types of data, such as watershed maps that show changes in stream flow that students could use to identify drought risk. I'd also like to point out that the clarification highlights a contrast between phenomena that are reliably predicted and those that are not yet predictable. This contrast was not even alluded to in the three dimensions, so this part of the clarification raises more questions for me than it answers, so I'll make sure to revisit this point as we continue. So we're able to add a little more very specific information to the table, including the kinds of data to focus on for the analyses in the practice, and specific types of hazards to focus on for the DCI. This is really helpful in narrowing the scope of the learning goals for the PE. A few minutes ago, you described what you thought it would mean to assess this PE. Take a moment to reflect on how a close reading of the three dimensions and the clarification statement influenced your ideas about the goals of this PE. Do you still have questions about what you would need to know about your students to monitor their progress with this PE?